Bismillahirrahmanirrahim. Welcome to the second part of the definite integral. As we stated in the first part, we said that the definite integral can be written or equal to the limit of Riemann sum as n goes to infinity, where the definite integral is a function defined or continuous over a closed interval a and b. The first step was to partition the interval a to b into n subintervals. Then we find the xi's. Then we can apply the limit as n goes to infinity to evaluate the definite integral. Some other cases we can approximate or estimate, this estimation, not finding the exact value, of the definite integral using the midpoint rule. Where the midpoint rule is given by, we can say the definite integral f of x dx is approximately equal to sigma I from 1 to n of f of xi bar. Xi bar means the midpoint, defined by this expression. It is 1/2 xi minus 1 plus xi divided by 2, or just 1/2 times xi minus 1 plus x1 xi. It is the midpoint of xi minus 1 xi. So the midpoint rule said that just multiply delta x by the value of the function evaluated at the midpoints of the subintervals. Delta x multiplied by the sum of the values of the function given at the midpoint of the subintervals. For example, in these two examples, we need to use the midpoint rule with n equal to 4 to approximate the integral. For example, question number 9 from 0 to 8 x squared dx. I need to approximate this integration 0 to 8 of the function x to the power 2 using the midpoint rule. So in the first step, we need to find the subintervals, or delta x also. So delta x, which is equal to b minus a divided by n, that's equal to 8 minus 0, n is equal to 4, given there. So we'll have 2. So delta x is equal to 2. So I'll have xi, or x0, which is equal to a, or in general, we know that xi is equal to a plus I delta x. So x0 is equal to 0. x1, it is just adding 1 delta x is equal to 2. x is 2 equal to 4. And x3 is equal to 6. And x4 is equal to 8. Now I need to find the midpoint for each subinterval. The first one, x1 bar, it is 2 plus 0 divided by 2, which is equal to 1. The second x for the midpoint, 2 bar, that will be 2 or 4, say 2 plus 4 divided by 2 is equal to 3. And to make it easy, it is that if we find the first midpoint, then we add 1 delta x each time. Delta x is equal to 2. So 1 plus 2 is equal to 3. Now 3 plus 2 will give me the third midpoint. So x3 bar is equal to 5. And the fourth one, between 6 and 8, is equal to 7. So these are the midpoints, are 1, 3, 5, and 7. I'm going to evaluate the function at the given midpoint. So the integral now from 0 to 8, x to the power 2 delta x can be approximated by delta x multiplied by f of 1 plus f of 3. We are evaluating the function at the midpoint, plus f of 5 plus f of 7, which is equal to delta x is given by 2. Now the first one, my function is x to power 2. That is 1 to power 2 plus 3 to power 2 plus 5 to power 2 plus 7 to power 2. That's equal to 2 multiplied by 1 plus 9 is 10, 35, and 49 is 84. Multiplied by 2, that is 168. So the integration is equal to 168. So this is approximating the definite integral using the midpoint rule. For the second one, number 10, I have 8x plus 3. Question number 10, 0 to 2 of 8x plus 3 dx. Let's check. Yes. So in the first step, I need to find delta x. Delta x equal to 2 minus 0 divided by 4, which is equal to 1/2. Now xi is equal to a plus a is equal to 0, so I will have I multiplied by delta x. That will be I times 1/2. This will give me, start with x0 equal to 0, x1 equal to 1 delta x, which is 1/2, x2 is equal to 1, x3 equal to 1/2, and x4 is equal to 2. Now we need to find the first midpoint. x1 bar, that is equal to 0 plus 1/2 divided by 2 is equal to 1/4. Then just add 1 delta x each time. So this is equal to 1 or 25. Then x2 bar, just add 0.5, it will be 0.75. Delta x is equal to 1/2 or 0.5. You can write it as 0.5 plus 0.25 is equal to 0.75. Next one, x3 bar, just add 0.5, that will be 1.25. Next one, x4 bar is equal to 1.75. So these are the midpoints. Now we can estimate the integration from 0 to 2 of 8x plus 3 dx to be equal to delta x multiplied by f at 0.25 plus f of 0.75 plus f of 1.25 plus f of 1.75, which is equal to 1/2 multiplied by, now 8x plus 3, just replace x by 0.5 or 1/4, will be the first one is equal to 5. The value of the function at 0.25 is equal to 5 plus second one, replace x by 3/4, so we'll have 9. Just evaluate. What I have 8 times x, which is 3/4. Cancel this with this one. I will have 2. 6 plus 3 is equal to 9. Next one, 1.25. That is 5/4. times 2 or times 8, it will be 10 plus 3 is equal to 13. Next one, 1.75. That will be equal to 17 in this case, because we have 14. Yeah, okay, this will be 17. Let's check this one. Now add everything together. We will have 5 plus 9 is equal to 14 plus 13 is equal to 27. 44 divided by 1/2, which is equal to 22. So the value for this definite integral is equal to, or approximately equal to 22, using the midpoint rule. So again, in the midpoint rule, the first step we need to find delta x, then we need to find the midpoints, then we can apply or evaluate the function at the midpoints, find the sum multiplied by delta x to estimate or approximate the given definite integral.